Alright, we're going to start Unit 10, and today we're going to talk about direct and inverse variations. If you look at the top, these come out of sections 2-3, that's direct variation, and 9-1, kind of the first part of it, if you're looking at that online textbook. So we're going to start with a direct variation, and a direct variation is a relationship between two variables where one is actually the multiple of the other. So the general form, as you're writing that definition down, is what I have right here. Y equals k times x. Now k is just some number, or represents some number, so k in an actual equation would be filled in with a number, but that's called the constant of variation, and that's how the two variables are related. On the graph to the right here, you guys see I just have several examples of direct variations. If you look at here, each one of these goes through the point 0, 0, and if you wrote the equations of these lines, this is going up 1 over 2, so this would be 1/2 x, this line right here. Your k value in that case would be 1/2. This one looks like it's going up 4 over 1, so this line right here, the direct variation would be y equals 4 times x, and the k value there would be 4. And this one here, and you can have a negative k value, and that's what's going on with this line right here. This looks like we're going down 3 over 1, so negative 3x. So those are just some examples. The k value can be positive or negative, but it's what we call a direct relationship because y is going to be a multiple of x. Okay, now, if you've given a table, which we've got going on in example 1, and you guys can see I've already worked through several of these problems, so I'm just going to go through and kind of explain what I did. So given a table, you have to test all the different points in the table that are given to you, so each one of these has 3 sets of coordinates. And what I did down here, I just took that y equals kx, and if you solve that for k, for any direct variation, you would divide both sides by x. So the k value should be the y coordinate divided by the x coordinate for any direct variation. So if you're deciding if something is a direct variation or not, you want to test to see if the y coordinate divided by the x coordinate is the same for each of the points. So that's what I did. I just did, for each one of these, k has to be the y coordinate divided by the x coordinate. As long as that's the same number every time, that's going to be your k value, and that will be a direct relationship. So in this table, I did 4 divided by 2, 8 divided by 4, 32 divided by 16. All of those were 2. And then you guys, here's my general formula up at the top. Whatever that number is, that's your constant of variation. And so to write an equation then, it's just y equals 2 times x. If you're looking at this table in the middle, remember it's the y coordinate divided by the x coordinate. So in each one of these cases, this is a fraction, which is totally fine though. We saw that in the graph up the top. Each one of these reduces to a third. So your k value is 1/3 here. This is a direct variation. The equation would be y equals 1/3 x. Now, when I got over here to this table, I was looking pretty good on the first 2 points, but I got down to the third point, which was 742. And since that was 6 instead of 2 like the other coordinates, that's not a direct variation. Maybe there's a relationship there of some kind, but it's not direct. It has to be the same number, y divided by x, for each of the points. A little bit different in example 2. This is just say, is this a direct variation? So basically what you're looking for here is, could you write this as y equals k times x? I don't have anything added or subtracted over here, so I should be good to go. This is a direct variation. The k value would be 5 over 4. Very similar thing going on here. I would just tell you, let's get y by itself. As long as you don't have anything added or subtracted, then you've got a direct relationship. This is a yes, and from there your k value is 2. Now, you can, in this question, divide everything by 3. This is the equation of a line, but because you have something added here, or subtracted if it was a different problem, that can't be a direct variation. It just has to be y and then some number multiplied by x. That's the only time it's going to be a direct variation. And then down here at the bottom, it says find the missing value for the direct variation, write the equation of the direct variation. So here I'm giving you a couple pieces of information. It says if y is 4 when x is 3, find y when x is 6. Okay, so I'm told this is a direct variation. I'm not told the k value, but I am told that y is 4 when, x is 3. So I'll pretend that was a parenthesis. Now, if I divide both sides by 3, that will give me my k value. If we're supposed to write the equation, that would just be y equals 4/3 times x. And then a lot of times these problems will ask you to do multiple things. So here's my k value, here's my equation, and then it says find y when x is 6. So I know the constant of variation is 4/3. When x is 6, what's going on with y? Here, think about that as 6 over 1. 4 times 6 is 24, divided by 3 is going to mean that y would be 8. Similar problem right next to this. I know I have a direct variation. It tells me that in the directions. I'm told that y is 10 when x is -3. So if I divide both sides by -3 real quick, our k value is going to be -10/3. The equation would be y equals k times x, where we know that k is the -10/3. And then find x here when y is 2. So this is a little different than the last problem. Y is, -2. This is -10/3 times x, so we're going to solve for x here. I would just multiply by 3 on both sides to get that out of the denominator real quick. And then I'm going to divide both sides by -10, and those negatives are going to cancel out, so we would have 6/10, and both of those numbers are divisible by 2, so missing x value there would be 3/5. Alright, one more set of problems. This is just giving you coordinate points. Each ordered pair is from a direct variation. Find the constant of variation k and then write the equation of the direct variation. So I know this is a direct variation. I know the y coordinate is 1/3. We don't know the constant of variation here at the very moment. But I do know the y coordinate and x coordinate, so we can solve for that. So I'm going to divide both sides by 3. Now, more of what I was doing here was trying to see how you guys would deal with dividing fractions here. Dividing by 3 is the same thing as multiplying by 1/3, so the k value here is actually going to be 1/9. So it asks you for the constant of variation, and then you're supposed to take it just one more step and actually write the direct variation relationship. So right here would be what I would do for my equation. Now again, same concept. I know this is a direct variation. The y coordinate is 2/5 here, and the x coordinate is 5/7 here. So this is just some fraction work to practice a little bit. So we have, I like to call this keep, change, flip. You're dividing 2/5 by 5/7. That's the same thing as multiplying by the reciprocal. So I'm going to keep the 2/5. I'm going to change that division symbol to a multiplication, and when I flip this, keep, change, flip, then I'm multiplying by the reciprocal. This would be 14/25. That doesn't actually reduce, but that is your k value, and then your direct variation here for that set of points would be y equals 14/25 times x. Now, we are going to talk about one more type of variation, and that's called an inverse variation. And if you're looking at that online textbook, this is going to be where we're going to switch sections, and we're going to come out of Chapter 9. This is Section 9. Okay, now, I went ahead and wrote down the formula here. So a function of the form y equals k over x. K is still going to be a constant of variation here. It's not equal to 0. When you have this situation, an inverse variation, when one variable increases, the other decreases. It depends on what your k value is. In a direct relationship, if if your x's get bigger, your y's get bigger. If your x's get smaller, your y's get smaller. So in a direct relationship, the variables move in the same direction. They either both get bigger or they both get smaller. In an inverse, they're going to go opposite directions. So as x gets larger, y would get smaller, or as x gets smaller, y would get larger. So they go in opposite directions. Another important thing here would also be to solve this equation for k to help you find the constant of variation. This is your general form of an inverse variation. If you solve this for k, what you would do is you would multiply both sides by x to get that out of the denominator. So in this case, the constant of variation should be the y-coordinate times the x-coordinate. Alright, so if this is an inverse variation, find the constant of variation k and then write the equation for the inverse variation. So here's your general form. You're going to want to know that. And I'm going to put 5 in place of y and 2 in place of x. Just multiply both sides by 2 real quick. That's your constant of variation. Now the actual question says let's write this as an inverse variation. So I'm going to go ahead and substitute in my constant of variation as the 10, and that's what they're looking for there. Same thing here. The inverse variation, 28 is the y-coordinate, is k over x. X is a fourth here, so to get that out of the denominator, we're going to multiply both sides by a fourth. So that's going to tell us our constant of variation here is 7, fourth of 28. So my inverse relationship formula would be y equals 7 over x. Both of these would show how to find the equation of an inverse variation. Now we're going to come down here. Suppose that x and y vary inversely. If you see that, that means it's an inverse variation. And they say x is 7 when y is 4. Find the function that models the variation, and then we're going to do another step, which is to find y if x is 14. So I've got a couple points going on here. Let's go ahead and plug these in. 4 equals k over 7. If we have the coordinates of the 2 points there, I'm going to go ahead and multiply both sides by 7. So 28 is my constant of variation. The formula here would be y equals 28 divided by x, so that's part 1. Part 2, once we've got our equation, we're good to go here. Find y if we know x is 14. So if that's the case, I know my constant of variation for this situation is 28 and the x-coordinate is 14. So for that, all I would need to do is divide 28 by 14. So 2 answers to a lot of these questions. Similar problem. X and y vary inversely. We're just practicing this again. So y is 15 when x is -5. So I'm just getting used to this format. Y equals k over x. I know the x and y coordinates. We're going to use this to help us solve for the constant of variation. I'm going to go ahead and multiply both sides by -5. And 15 times -5 is -75. And so then we're just going to go back and write the variation equation here, which would be y equals -75 over x. And you could put that, I mean, you could check that back real quick right here. If I did -75 divided by -5, that's 15, so it's easy to check. Second part of the question, a little different than the previous problem. They're going to give you a y-coordinate and ask you for x. So here's my formula. If y is 3, what's x going to be? Now, there's a couple different ways you could do this. If it was me, I would probably just real quick multiply both sides by x to get that out of the denominator. And then all you would need to do is divide by 3, which would give you -25. And that's super easy to plug back in and check. And that's your inverse variation.